Suppose you're on a game show and you're given the choice of 3 doors. Behind one door is a car, behind the others, goats. You pick a door, say number 1, and the host, who knows what's behind the doors, opens another door, say number 3, which has a goat. He says to you, do you want to pick door number 2? Is it to your advantage to switch your choice of doors? Some of you have surely recognized this problem as the Monty Hall problem, but even if you know the answer, stick around, because I think this video has something new to offer to you. We're going to look at a bit of the history, but also we're going to look at an intuitive understanding of the answer. We're going to get empirical proof that the answer we give is correct, and we're going to learn some life lessons at the end of the video from this veridical paradox. So stick around, but now we gotta get going before I get cut off by the Different versions of this problem have existed in a long time, but the first time it was posed and answered in this variation particular was by Steve Selvin in a letter to the American statistician in 1975. It's important to note that Selvin clarified that their solutions and for the problem has 3 different important rules. First rule: the host must always open a door that was not picked by the contestant. Second rule: the host must always open a door to reveal a goat and never the car. Third, the host must always offer the chance to switch between the original chosen door and the remaining door. By the way, it's called Monty Hall Problem because it's named after a person called Monty Hall, who was the original host of a TV show called Let's Make a Deal in the US. But he himself actually on that show never gave the choice to switch doors. What he instead did, he opened a door, like in the puzzle, but then he gave the viewers the choice to pick between what's behind their own door or $100 in cash. And in fact, Monty Hall told Selvin, and if you ever get on my show, the rules hold fast for you. No trading boxes after the selection. Okay, so now we know the history, where the problem came from, and the exact problem statement. And we promise we're going to get to the solution in just a second. But before we do that, I want you to imagine yourself in that situation and decide what feels better to you. Would you change, or would you stick with your own door? And if you know the answer, try to ignore the answer and just see what feels right in that moment. Leave a comment with what you would be doing. So, the first intuition seems like you have a choice between 2 doors and it's a 50-50 chance. But that is not correct. Before we pick our door, there are 3 possible scenarios. The car could be behind door number 1, the car could be behind door number 2, or the car could be behind door number 3. These are the 3 only possible scenarios.
And now, in each one of these scenarios, we will pick every possible door to again get every single possible scenario that could happen up to this point. Let's start by picking door number 1 in every scenario. And then we simply look at what we need to do to win. In case number 1, we stay. In the other 2 cases, we switch. And now what we need to do is look at the case where we pick door number 2 and door number 3, and then add up all the sums of how often we should be switching to win and how often we should be staying to win. So far, the sum total is 1 for staying, 2 for switching. Okay, let's pick door number 2 and see what happens. In this case, we should be switching in case 1, staying in case 2, and switching as well in case 3. We will add these to our sum totals. Staying goes up from 1 to 2, and switching goes up from 2 to 4. Maybe we'll start to see a pattern, but let's look at our last case, the case in which we pick door number 3. Here, we should be switching in case 1, switching in case 2, and staying in case 3, bringing our sum totals to 3 for staying and 6 for switching. Okay, so now we've looked at every single possible situation that can happen, and we have counted how many times we should be switching and how many times we should be staying, and these are our sum totals.
So this means that if we switch, we are twice as likely to win car. That's weird. It's important to remember though that if you switch, you're not guaranteed to win. It's just twice as likely. I see some of you are still skeptical, so let's go into and do some empirical proving. So I'm a software engineer, and so I thought maybe we can build a simulator that runs all of this, since it's just statistics, to prove that this answer is truly correct. So let's go to Philip in the software engineering studio. Thank you, Philip in the forest. So I've programmed all this out in Python, was the quickest solution, and it's much easier than people may think. The code is publicly available on Github, and anyone who wants to check that work can and should do so. Link is in the description.
So the way the program works, it essentially 1 million times stay with its original choice, and then afterwards it will switch its choice 1 million times and collect the results of how often it won and how often it failed. So let's have a look at what happens. And here are our results, and it shows that we are correct. By staying with our original door, our simulation won 333,710 times and lost 666,290 times. So that means it lost 2/3 of the games. On the other hand, when our simulation switched, it won 666,768 games and lost 333,232 games. So those are the results from our simulation. It is true, 2/3 of the times you will win if you switch your door. Alright, that's it from me in the studio. Thank you very much, and back to you, Philip in the forest.
Thank you, Philip in the studio. So I promised you a life lesson to learn from this paradox, and this is coming in now. But to be able to learn that lesson, we need to understand the reason why actually most people prefer to stick with their own door rather than switching. There are 3 main reasons psychologically that have been discovered why humans want to stick with the door. Number 1, the endowment effect.
People tend to overvalue the winning probability of the already chosen, already owned door.
So we kind of value things that we own more than things that we don't own yet. Because people have the feeling that they own door number 1 already, they are more likely to stick with that door than giving it up for the very same thing. Number 2, the status quo effect.
People prefer to stick with the choice of door they have already made.
That basically describes that people on average are more likely to stay in the situation they're in than actively initiating a change to it. And the third one, which I think is a really interesting one and that we can learn a lot from, is the era of omission versus the era of commission effect.
All other things being equal, people prefer to make errors through inaction as opposed to action.
So if you pick the wrong door, you'll feel better if you didn't switch than if you switch and you had originally the right door. You feel like that's a worse mistake. So people prefer to make mistakes by not doing things than making mistakes by doing things. The lesson to learn, I guess, is we are twice as likely to win a car in this fictional game show if we change. But we do need to go against our natural instincts, overcome these basic psychological effects, endowment effect, status quo bias, the era of omission versus the era of commission effect, to be able to get that benefit. In a lot of situations we act by what we feel is right, but that's not always the best choice. In this case, if we spend a little bit of time to understand the problem ahead of us, we can actually double our chances of succeeding. And in real life, we're unlikely to be on a game show where we get asked if we want to swap our doors. But we will be in situations where we have to make decisions, and we're still going to be inclined to follow the same psychological principles. And how many proverbial goats have I gotten in my life because I didn't evaluate the choices that I had in front of me properly and I made the wrong one? So by learning from this example that we need to look at situations properly, understand their outcomes, we can maximize our success in life. I hope this was helpful to you. I really enjoyed making the video, and I'll see you next time. Thank you very much.